Welcome back to another video. Today we're going to be looking at the following problem from Mathcounts 2021. And we have a read of the problem below, and let's get started. So it says, Tim has a collection of square tiles of various sizes, each of which has an etched quarter circle with radius equal to the side length of the tile. Tim arranges 8 tiles as shown below. And if the two smallest tiles each have side length 10, what is the length of the resulting spiral formed by the tile's etchings? And we have to express our answer in terms of pi. Okay, so if we zoom into this a little, we can see so we have our 10 tiles, right? Or 8 tiles. And the two smallest tiles have a side length of 10, it said. Let's just confirm, yep, a side length of 10. So this means this has, sorry, a little bigger. So, okay, so that means that the two smallest ones have side length 10. So if we look carefully at this, right, looking carefully, we can see that the square above these two is just twice the side length of the smaller two squares, right? So let's see if we can do this. If these two are 10, that means this is 20 right here, right? Because 10 plus 10 is 20. Now let's look at this side length right here. This side length here is just the 20 plus 10, right? We have this is 10, this is 20. So this becomes 30. Now let's take a look at this side length right here. So this is 30, this is 20 right here. So we get 50. And then now if we look at this side length here, it is just 50 plus 30, which is 80. Now if we want to find this side length right here, we would take this 80 and we would add this 50 right here, which is this much, get 130. And then lastly, our biggest piece is just 130 plus 80, which is 210. So you might recognize these numbers. These actually are Fibonacci numbers, right? So if we have basically, if we divide everything by 10, right, that shouldn't make a difference. We're just scaling our problem down. The first two have a radius of 1, then the next one has a radius of 2, then you have 3, 5, 8, 13, and then 21. And Fibonacci numbers, for those of you that might not know, it's the sequence of numbers where each term is found by adding our previous two terms, right? So 1 plus 1, you get 2. 1 plus 2, you get 3. 2 plus 3, 5. 3 plus 5, 8, and so on. That makes sense, right? Because looking at this diagram, we can see that all we're really doing is adding the two previous tiles to get to our next tile. Okay, but anyway, so now that we have this, we can look at what is the question asking? We're asked to find the length of the resulting spiral, right? So the length of the spiral, the length of the spiral, we're going to find just by looking at each individual arc and then adding it all up at the end, right? So if we start inside, and let's use our smaller numbers, 1, 1, 2, 3, 5, 8, 13, and 21, just to make calculations easy, and then we'll go and add or multiply everything by 10. So if we start off with the smallest arc, we have two arcs, each of radius 1, right? So if we think about this generically for a second, what we have is basically, if our radius is, say, r, then the length of the quarter circle would be what? Let's figure that out. So basically we have if you have a circle with radius r, the circumference would be 2 pi r. So that means that a quarter circle, which is just 1/4 of this, would be 2 pi r over 4, or just pi times r over 2. So this means given our radius, we can find the length of the arc to just be pi over 2 times that radius. So rather than going through and finding each arc individually and then adding it up, what we could do is just think about it more generically. If we let r represent all of the possible radius, or we should say radii, of our different arcs, well, we have to just find the sum, this is just summation notation, of pi r over 2, right? Where r ranges from all of our arcs. And basically we have r is equal to 1, then 2, 3, 5, 8, 13, and 21. So pi over 2 is constant, right? Pi over 2, we're always multiplying. So what we could do is actually say we have pi over 2 times the sum of all of our radii. And now this is pretty easy to do, right? Because all of our radii, so this is just pi over 2 times 1 plus 1 plus 2 plus 3, 5 plus 8, let's get some more space, plus 13 plus 21, right? This is because every time we distribute the pi over 2 to each term in our sum, it would give us the arc length of that of that quarter circle. So this is just pi over 2 times, adding this up, you get, this is 2, this is 8, and then, so basically you have 2 plus 2 is 4, 8 plus 8 is 16, so that's 20, that's a total of 20, and then you add these two, which is 34, you get 54. Right, and now this we could simplify to just 27 pi. And now we have to be careful because we're almost done. We just need to remember that we scaled our entire diagram down by 10, right? All of our radii we divided by 10 just to make the number smaller and more manageable. So we just can't forget to multiply by 10 again. So in reality, our answer is 27 times 10, 27 pi times 10, I should say, which is 270 pi. And this is our final answer. So that should conclude the problem for today. If you have any questions, be sure to leave a comment. Otherwise, if you enjoyed the video, feel free to like or subscribe, and we will be back again with another video tomorrow. Thanks, Devin, for joining, and I'll see you again in the next one.